Ladies and gentlemen, I am Shima Timsani. I am currently a second-year PhD student at the National School of Applied Science, Ibn Tufa University in Kenita, Morocco, where I am part of the System Engineering Laboratory. It is my pleasure and the honor to participate in this conference. Today, I'm excited to present our research about Modern Data Stack Demystified, a strategic framework for scalable adoption. To lead this presentation, I expect to give, after the introduction, an overview of the modern data stack. Then I will explain the main challenges that organizations face. And finally, present our modern data stack adoption framework before concluding with key takeaways and outlooks. The digital transformation has flooded organizations with huge, diverse, and fast data, often described by the three V: volume, variety, and velocity. Cloud services and open source engines like Apache Spark and Kafka lowered the barrier to build many pipelines, but too many specialized tools added in an ad hoc way can turn the platform into a technological zoo, hard to trust and expensive to run. So, we need a fast, resilient, and well-governed data platform. The motivation for a modern data stack. After this, our paper looks at the history of data systems. We started with the relational database in the 1970s, then moved to data warehouses in the 1990s, and in 2010, we saw the rise of data lakes and Lambda architecture. Each of these innovations solved important problems, but each also introduced new layers of complexity. This evolution brings us to what we call now the modern data stack. Today's stacks built on the history with several key ideas. Data lakes, for example, provide low-cost storage with schema on read, making them well suited for raw and mixed data formats. Lakehouses build on this by adding asset transaction, schema enforcement, and governance with platforms like Delta, Iceberg, and Hoodie. Data Fabrics takes a different approach, creating a unified way to access scattered sources through catalogs, knowledge graph virtualizations, and API. And Data Mesh focuses on organizational change, shifting ownership to domains, treating data as products, and supporting self-serve platforms with federated governance. In reality, most organizations don't adopt just one of these approaches. Instead, they use a hybrid approach depending on the use case. That is the modern data stack in practice, the product of decades of evolution. The modern data stack can be understood as an end-to-end toolchain that covers the full data lifecycle. It starts with ingestion, bringing in both batch and streaming data. Then comes storage with multiple options such as warehouses, data lakes, lakehouses, or NoSQL stores. After storage, data must go through transformation, either through ETL or ELT pipelines or real-time processing. Orchestration ties these steps together, ensuring automation and reliability. Finally, the data is used in the conception layer, powering business intelligence, dashboard, APIs, or machine learning applications. Across all these layers, governance and observability ensure quality, security, and trust. Keeping the data accurate, consistent, and accessible across many tools is hard. Syntactic standards help systems connect, but we also need semantic interoperability, shared definition, rich metadata, and end-to-end lineage. So meaning travels with the data. Without that, teams teach things by hand, deliver slow, and quality drifts. The answer is the right balance, central policies and standards where it matters, autonomy for domain teams and operational guards, catalogs, data contract, access control, and quality KPIs. This is exactly why our framework ties governance and security with operationalization and observability across all phases. In hybrid and multi-cloud environments, privacy by design and compliance across jurisdiction are difficult. We need clear ownership, auditable controls, and policies that follow data wherever it goes. Without observability, the stack is a black box. We must monitor freshness, latency, schema changes, and quality, and connect incident to root causes with end-to-end lineage. Scaling is more than compute. Pipelines should be resilient and auto-scalable, with good error handling and idempotency. Hybrid multi-clouds add latency, data movements, cost, and policy drift. Poor control leads back to the costly technological. Considering this, modern data stack reveals opportunities and difficulties. The stack's flexibility enables faster insights and new value, but teams must adapt methods to deal with governance, interoperability, security, observability, and scalability. This pressure changes on how we manage data and motivate a structured framework so adoption is gradual, measurable, and aligned with business needs. Our proposed framework enables to organize adoption across six temporal phases, mapped to six functional domains, according to the organization maturity and priorities. In this framework, we have the six temporal phases. The first one is strategy definition. Define data vision, principles, and target outcomes aligned to business scope priority use cases. The second one is maturity assessment. Evaluate current governance, infrastructure, data quality, organization readiness. Involve the right stakeholders. Third one is gap analysis. Identify missing skills, technology, processes, culture, prioritize action and risk. The fourth one is transformation management. Plan and deliver POVs, increments, manage change with KPIs and fast feedback. The fifth one is success enablers. Develop skills and culture, integrate governance by design, standardize platform and access mechanisms. The sixth one is roadmap and continuous improvement. Execute by stages, perform regular reviews, KPIs and maturities, then adjust scope and pace. On the six key functional domains, we find first the strategic alignments, connect data goals to business values, break silos, set a recurrent assessment cadence. Secondly, architecture and stack design. Choose modular, loosely coupled components, standardize access layers and interfaces. The third one, governance and security integration. Define policies, ensure lineage, quality KPIs, access control, and compliance. The fourth one, operationalization and pipeline orchestration. Automate workflows, apply testing, observability, and lineage end-to-end. The fifth one, organizational enablement, clarifies roles and ownership, domain, data, product, adopt data ops practices. The sixth one, iterative evolution, use KPIs and maturity model to steer action and start multi-speed feedback cycles. To conclude, a modern data stack can unlock value, but without structure, it becomes a fragile, costly ecosystem. Our framework connects strategy, architecture, operation, culture, and embeds quality, security, and observability from the start to continuous improvements. They are central throughout the framework. Governance, access control, compliance, and auditable policies must be in place at every step. Our future work will focus on how can we improve metadata compatibility between open source and commercial tools to strengthen semantic interoperability and make adoption smoother. So this is the end of my presentation. Thank you for listening. I keep myself attentive to respond to your remarks and questions. Thank you.